Let's continue with our chapter 4. In this section, we are going to go over example and problems to get a better idea of how to solve series circuits. So right here, they are giving us a description of what a series circuit is. So we are going to go from point A to point B. So we have R1 and R2. We only see that in order for these two resistors to be connected in series, there can only be one single common point, only one connection between R1 and R2. If there are more than a single connection, or if there is anything connected between them, they are no longer in series. But in this case, the current comes through here, goes through R1, goes through this connection, then goes through R2 and gets to point B. So these resistors are connected in series. One common terminal and no other component has a terminal that shares that common connection. So there can be nothing connected here for them to be series. And they don't have to be a straight path like this. They can be connected like this. You see, it's all random. But as long as we can trace a single path and a single point connection between the components, they are considered to be a series circuit. Because the definition of a series circuit is that the current has only one path to go through. It doesn't have options, but only one way to go through. So we go from A, we come here, the single connection, then we move on, we go through this resistor, single point connection through these two resistors, then we go across, we go through here, single point, go across, single point, and then we end at B. So those resistors are considered to be in series. How do we find the total resistance? The total resistance, like in the lecture was described, is the algebraically summation of all the resistors in the circuit. So we have a basic circuit here. This is a circuit because we have the voltage source, we have the closed path, and we have a load. In this case, the load, it's distributed among three different resistors. So in order for us to find the equivalent resistor or resistance, we are going to add them. R1 plus R2 plus R3 plus R4 is going to give us our R total. The general form is that the R total, or the total resistance, is equivalent to the summation of each individual resistance, whatever that number might be, to to Rn. So once we have the R total, we add them 10, 30, 5, and 20. We're getting our total of 65. Example 4.4 says find the total value of the resistance. So they give us a source, and then they give us, first we check if they are in series, and they are, because there is nothing connected between them, and there is a single point connection for all the resistors. So we have ground and ground. We could have connected this by a single wire and have a single ground, or we can have two grounds like here. It's the same thing. So we just add them individually and we get 17.9. Then for part V, if we see it's the same value of the resistors, it is just that it is arranged different. The 4.7 now is the first, and we have the 10 the second, the 1 is the third, when here it was the first, and then we get the same value. So what this example tries to explain is that it doesn't matter how you move the resistors across the circuit. As long as they are series, you can move them however you want it, and it doesn't affect the circuit itself. So in other words, the resistance doesn't depend on the position of the resistor. A and B are identical in terms of resistance. So circuit A has 17.9 kilo ohms, circuit B has 17.9 kilo ohms as well. So they are the same. The orientation of the resistors are different, but it is the same. It is the same total resistance. Example 4.5, it says determine the value of the R4, resistance number 4. So we have the voltage source, so we have an ohm meter measuring from this point to ground. So from this point to ground means across all these resistors. So we want to find the R4. In order to find the R4, we know the formula says R total is equivalent to R1 plus R2 plus R3 plus R4. we have our total in this case. We have R1, R2, and R3. So we solve for R4, and R4 happens to be 56 kilo ohms. A special case. So in these special cases, when we have a circuit that has multiple resistors with the same value, so we can say that the R total is the number of the resistors multiplied by the value of that resistor. So in this case, we have the voltage source. We have 1, 2, 3, 4. N is equals to 4. They are all the same value, so we just take one of them and we multiply it by 4, and that is our R total. So this is a special case when we have several resistors with the same value. We just don't need to add them individually. We just get the multiplying factor, which is the N. Current in series circuits. As we define it in our lecture section of chapter 4, we said that the current in a series circuit is the same across all the points. Each resistor has the same current, and this is true because current can only go through this path. So current doesn't leak into anything else. Current, if it gets produced by here, it goes and it has to go through here, through this resistor, through that resistors, all the way to the other terminal of the voltage source. That's why the current, it is constant across a series circuit. So we can say that the I source produced by the source is defined as your voltage source divided by your total resistance, not by R1 or R2, by R total, which is R1 plus R2 plus R3 plus R4. That is our R total to give us the I source. And then we know that I1 will be V1 over R1. So if we want to find the current here, which is the same as the source, we know that we have to find the voltage across this resistor. But it would be easier to find it from the source because we have the voltage is usually given to us. So from there we can say, okay, I source is equals to I1 equals to I2 equals to I3 equals to I4. So it is constant all across. The voltage, on the contrary, the voltage it is split across each individual resistor. So V1 will be I source times the resistor. V2 will be I source times resistor number 2. V3 is going to be I source times resistor number 3, and V4 is going to be I source times resistor number 4. In a way that the V total or the V source is going to be V1 plus V2 plus V3 plus V4. That's how we will find each drop across each resistor. So in a series circuit, we can conclude that the current is the same, but the voltage is divided. The voltage divides across each resistor. So series circuits a lot of the times are considered voltage dividers, and we will see this toward the end of this example and problem videos. So in 4.7 they are said, okay, find the current in the circuit. So find the current in the circuit. The first step is they are giving us the voltage, they are giving us each individual value for the resistors. So I find the R total to be 1580 ohms. Then my I source is going to be V source divided by R total, which is 25 divided by 1580 ohms. So we have the resistor to the current to be 15.82 milliamps, which as we know that I source is the same as I1, I2, I3, I4, and I5. So let's stop right here.